since you now know that whole square root business stuff, today's little lesson is just about irrational numbers. Irrational numbers. And basically, for all intents and purposes, for you, irrational numbers are simply square roots that don't work out. We talked about that yesterday. It's simply irrational because if you try to work them out nicely, you end up with a non-repeating, non-terminating, which means goes on forever decimal. The only other thing for right now you need to understand that is also irrational is this little guy right here. The pi thing. Okay? And just delving a little deeper into the irrational numbers there, we talked about, you have to be able to kind of estimate what they're about. Like if I said, I'm going to give you the square root of $3, you need to tell me just about what, something close to what that is. You have to have some idea what that irrational number is. And we do a little thing called the approximation. That's that little squiggly equal sign means it's close to, but it's not quite. And how do you know what the square root of 3 is? Well, you kind of do things like this. On a number line, we can have this, the square root of 1 would be 1. The square root of 4 is 2. Those are the perfect squares we talked about. The square root of 9 is 3. Where would the square root of 3 kind of fall in that long list? Well, it's between here and here. It's probably right about here. That would be the square root of 3. And what decimal would you pick? I don't know. I'd probably pick it's 1 point. What do we got? Did we ever talk about it? Maybe 1.6, 1.7? What's 16 times 16? Does anybody know? Let's look and see. Let's pull out the calculator again and give us the square root of 3. The square root of 3 is 1.732. 1.732. But you would never guess that, and you don't have to, and they're not going to ask you to guess that, but you need to know what two whole numbers it's going to fall between. For example, here's a problem. Arrange from least to greatest. From least to greatest. And I gave you this whole long list of numbers. 2. The square root of 5. 5 ninths. 0, 3, 1.2, and 1. I'll give you a second. Put those in order from least to greatest. Arrange those for me in order from least to greatest. What would you say? Write them down on your paper. From least to greatest. And maybe, just maybe, it would be helpful to look at these things on a number line so you can kind of see where they fit. Let's look at the numbers. We put it here. 2 obviously goes right here. Here's the number 2. The square root of 5. Where does the square root of 5 fall? Brenda, Nancy? Between what two whole numbers?
2 and 3.
2 and 3. Probably maybe around here, maybe. Let's just call it right there. Square root of 5. where is 5/9? More or less than a half?
It's like 4.
It has to be more than half of 9 is 4.5. So let's say 5/9 is right here. 0 we know is here. 3 we know is here. 1.2 we know has to be, this is 1.5, 1.5, so 1.2 is probably about right here. And 1 is probably right there. Right there. So if you're doing these from least to greatest, 0, 5/9, 1, 1.2, 2, the square root of 5, and then 3 would be your gist. Maybe it would be helpful for you to jot that down as a number right there. And then something else to look at would be this. This comes out of the book. If you know that this is a square, and you know that this is a square, and the area of this is 100 centimeters, and let's say the area of this is 10 centimeters. And I asked you to tell me how long are the sides of those squares. If you know, oh, by the way, this should be square, centimeters squared. If you know that the area of this is 100 centimeters squared, the one thing we know about squares is that all their sides are equal. What would the length of each side of this be, Charles? Same side. What the area is side times side there. This would have to be what times what would give you 100. 250 times 250 is all a huge number, way up. Yeah, but a square has to have the same side. It has to be the same number because a square has the same sides. Kevin? 10. Because 10 centimeters times 10 centimeters gives you 100. Now, using that thought process, what about this? You are looking for this. What number times itself gives you 10 centimeters squared? Now, we talked about this before. Where did we talk about what number times itself gives you a number? Square root. So the answer to this is S equals the square root of 10 centimeters squared. It's an irrational number, but that's what the answer is. The square root of 10 times the square root of 10 will give you this. I can tell you why. Because of this. Watch. The square root of 10 centimeters times the square root of 10 centimeters. When you multiply square roots together, you just multiply the numbers inside of that. Guess what you get? The square root of 100 centimeters squared. And what is the square root of 100? Nothing more than 10, which is what we had as the area of that thing. Okay, so if they give you a square and they give you the area of it, let's say the area of this is 3 inches squared, what would each side be? Using the same thing we did there. What same number times itself gives you 3? The square root of 3. That's how long a side is. Let's check and see. Just because we can. Where's my calculator? If this is true, if you take the square root of 3 times the square root of 3, you should get 3, right? What did we say the square root of 3 was close to? I just gave that to you. I said what? 1.7 what?
1.732.
So let's check this out. Clear this. Where's the clear button? Memory clear? No, where's the clear? There it is. So 1 point what? Sorry.
1.732.
1.732 times 1.732. I multiply those together, I should get something awful close to 3. I probably won't be exact, it'll probably be 2.999 something, but no, 2.99824. Now, had I wrote down more of the digits of the square root of 3, what else? Let's do that. 3 square root. Can somebody remember that? 1.73205. 1.73205. If I multiply two of those together, I'm going to get awful close to 3 again. Where my calculator go? Ready? 1.7325 times 1.7325. How many 9s do you think I'll get after my 2 this time?
4.
5, maybe 6. 2.99999. 7205. What comes after the 5?
Oh no, we're gonna get so many.
05, 080. 080. Let's see how close we can get here. This is exciting, kids. You can't just get this kind of fun in science class. 1.7320580 times 1.7320580. How many 9s do you think I'll get after 2?
Like 7.
A lot.
Ho Chi Minh City, 2.1234567 9s.
I had right.
So you can see that that's the whole